Hi everyone, this is Subnet Zero and welcome to my channel. So today we will be focusing on binary calculation, but before that, let's go through what the concept of binary number is, okay? So binary number is basically all about 0 and 1. What is the value of 0 and 1? In modern computers, everything, from communication to data to everything, the way it's processed is broken down into 0 and 1. Like imagine as I said a light switch. Zero means off. Sorry. Zero means off and one means on. Okay? Okay, zero means off and one means on. This is how the reference of it is in the modern world, okay? So imagine if you have these two switches, 0 and 1. So how will you calculate everything based on this? Okay, so now this video, we're going to focus on the calculation of the numbers based on these two binary. Now, based on this, let's play a game, okay, of binary calculation. Okay, so we have, remember the rules. Uh, yes, sorry. On is equal to 1, off is equal to 0. Okay, and remember, always, 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 it's 8 blocks. Okay, and remember the other rule number 2, 8 blocks, always. So based on this, first we will set the ground rules of how it should be calculated. Okay, this is 1. This is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Why is that? Let's get into it first. Why are we using these numbers? Okay, so first in the above blocks, the numbers, first 1 multiplied by 2, 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16, 16 multiplied by 2, 32, and so forth. Okay, so the top row goes from, the top row goes from right to left. Okay, and when it comes to the bottom row, that is its calculation, it goes from left to right. These are another rule, okay? And remember, it never exceeds more than 8 blocks. And now, keeping these 8 blocks in mind, how will we calculate a binary? Let's look at this, okay? See. You see this? This is like 1, 2, 4, 8, 16, 32, 64, 128. I made a replica of this over here. In the mustard yellow, and in the pale yellow, we will calculate how binary numbers are calculated with examples. Once we go through the examples, I'll show it to you one by one, okay? Now, keeping these very rules in mind, let's start calculating examples. And after the examples, binary will seem very easy. Okay, it will be very intuitive. So, yeah. Again, rules. It should never exceed more than 8 blocks, and yes is equal to 1. No, as in yes is equal to 1, that is on. Yes on is equal to 1. No off is equal to 0. Okay, these are the rules. Now let's get to a number, I don't know, 5 or let's say 3. Okay, now we start calculating from here. Is 128 is bigger than 3? Yes, we don't need 128. Then what about 64? Bigger than 3? Yes. 32 bigger than 3? Yes. 16? Yes. 8? Yes. 4? Yes. 2? No, it's not bigger than 3. So this will be useful. And what is left? 1. So you see, the binary of 3 will be 1, 2, 3, 4, 5, 6, 7, 8. Yeah. This will be the binary of 0. It can also be 0, 0, 1, 1. Also a valid binary number. Also 1, 1. All these 3 are valid binary combination representations of the number 3. Okay, so, and if you're confused, just remember it's like 9 a.m. or if you say, I don't know, 0900 hours, also valid. 9 a.m. also valid. 9 in the morning also valid. All these, since 9 a.m., 900 hours, 9 in the morning, all these 3 formats are valid. Similarly, like this 1, 2, 3, 4, 5. The 6 times 0 and 1, 1. Then 2 times 0, 1, 1. And then just alone 1, 1. All these three formats are also 100% valid, okay? So please don't get confused, but this is the correct binary. Now that I've cleaned up this board, let's look at, I don't know, the number, I don't know, 12. Okay, let's go. 128 is bigger than 12. Don't need it. 64 is bigger than 12. We do not need it. 32 bigger than 12. Do not need it. No. 8 is smaller than 12. This will be useful. Okay. And what we are remaining is 4. This will be useful. So 8 plus 4, 12. Pretty much sorted. We don't need this and we don't need this. So the binary of 12 will be, 0, 0, 0, 0. Okay. 1, 1, 0, 0. Want to check? Let's check. Binary of 12. See? 1, 1, 0, 0. Yeah, you see this? Binary of 12 is 1, 1, 0, 0. And we have 1, 1, 0, 0. Okay? Now let's look at a slightly complex number, that is 145. Okay? So in that 128 will be needed. Yes, 60. Now let's open up a calculator. Yeah, you see this? 145 minus 128 will be 17. Okay? So now this is the remainder of 17. We do not need 64. It's larger than 17. 32 larger than 17. 16 is smaller than 17. This will be useful. You see this? Yeah. Now now we remove 16. How much? We have 1. With 1, we only need this. Okay. And this is 0, 0. We don't need it. Okay. So now the 145 will be 1, 0, 0, 1, 0, 0, 0, 1. Wanna check? Let's check. Binary of 145. Let's check. 1001 0001. Let's see. 1001 0001. Bingo. This is how we have gotten the binary. Okay. Now let's say if they're all 0. Okay. Let's say if they were all 0. What will be the binary? 0, because pretty much there's nothing to it. Okay. But let's inverse the situation and all of this was 1. What would it be? This would be 255. Yeah? If you calculate 128 plus 64 plus 32 plus 2 plus 1, the total will be 255. And I want you to remember that this number 255 is extremely important later on, because 255 means the maximum limit it has hit. Beyond that, binary won't work. 255 is the maximum limit it can take. Again, this number, especially in the future networking video, you will see this number a lot in the future videos, okay? So I hope this gamified version was easy for you to understand. You understood how the binary is made. You can also find binary calculators on Google. You can just type binary calculators and you will find binary calculators of your own way. Again, this is an optional video for math nerds, those who are interested into getting into deep dives, how it works. This is how it works, okay? Even if you don't memorize this, it's completely fine, but you should understand the core concept, okay? I hope this was useful, and I'll see you in the next video. Bye.